I'll silver solder this. Hey, get back in there. Ow! Of course that's hot. Why did I not think that would be hot? Hello Internet, my name is Quentin and this is Blondihacks. I'm back on the vertical fire tube boiler today, and it's time to get all of the fittings attached to the boiler so we can actually start making some steam pretty soon, and that means another pressure test. So we're going to do all that right now. Here's the boiler so far, and here's the set of basic fittings that I've purchased for it. That's a PM Research pressure gauge that goes in the upper left, and then I've got a PM Research water gauge kit here. It's got all the different components here with a glass tube for different lengths of water gauge, and these two fittings go there on this side. Now I want to make some modifications. So this pressure gauge has a little elbow fitting on it with a little union cone, and it's designed to go roughly here. So all assembled it looks like that, but the fitting that came with it is much too small. I wanted to standardize the boiler bushings on my boiler on one side that's larger than this little elbow. Steam School sidebar. Are you wondering why there's a little copper tube on a pressure gauge and often it's in a little coil? That's called the siphon tube, and the purpose of it is to cause the steam that goes in there to condense into water, and then the pressure is read through the water, rather like the S-trap on a toilet creates a water barrier between you and the gases. The steam in the boiler would actually damage the Bourdon tube in the pressure gauge, so the pressure gauge is actually measuring water pressure that's been condensed in that siphon tube. So I'm going to make a custom version of that elbow and replace that rather than making a clunky adapter. So I'll take some measurements off of this to figure out what that thread is. It's a very tiny little female union cone. And then over on the water gauge, I want to do something similar. So this is the lower water gauge fitting, and it's supposed to go on there. It's basically a street L. Then the glass tube will fit in there. And what I want to do is add a globe valve to the outside, and this will be both the blowdown valve for the boiler and also a blowdown for the water gauge. On my last boiler, I learned that being able to blow down the water gauge is super useful because they get air bubbles in them and then they're not useful anymore. So over in CAD, I modeled up replacement fittings for those two parts that will have the threads that I want, and in the case of the water gauge fitting, it will be a straight through T that I can use to attach my globe valve. I decided to make the centers of these cubes so that I can put a wrench on them for easy holding and tightening and so on. These two parts have a lot in common, so I'm going to make them kind of in parallel here. So I'll mark and cut a couple of lengths of 1/4-inch brass square bar here to start with. These are pretty small parts, so the hacksaw will suffice. Get that first chunk out of there and then cut the second one off, and then I set them up in the mill and faced off the ends, using the other piece there to balance the vise jaw there. Always a good idea when clamping at one edge of the vise like this. So with one end faced clean, I flip it over and I face the other edge clean, and then once both ends are cleaned up, then I can measure the final length that I want, and I can mark that and then face it down to final dimension. So far so good. That's my little L-shaped fitting base there, and then I'll swap these parts and do the same to the other end. Now you might be wondering how I'm going to get a T and an L out of these pieces of square bar. Well, I'm taking a page from the book of Kozo Hiraoka, and I'm going to fabricate the rough stock that I need in the shape that I need, rather like you would with a casting. So here in the mill, I'm going to edge find and find the center line on the two vise jaws there using the half function on the y-axis, and then I'll also edge find one end, and then I'm going to set up an end stop here because I've got these two similar parts, and they'll both use the same end as a reference, so that'll save me some setup later. Now I'm going to go straight into the middle of the T section here with an end mill. I'm going to plunge straight down to a predetermined depth. The depth doesn't matter a whole lot. And what I'm going to do is I'm going to make another piece that fits in there, and that's going to form the rough casting, if you will, for this final part. So I'll do the same thing with the L-shaped piece. Again, using the same end as the reference surface. It's easy to move over to where that one needs to go. Then over to the lathe, I've got some scraps of round bar here, and I'm going to face the end of that and clean it up, as is tradition. That piece has got a bend in it, hence the run up, but that won't hurt here because we're going to be turning it down. So I'm turning a shoulder onto the end of this part that is a very good fit for the recess that we cut with the end mill in the square bar. So I'm taking my time here, deburring, measuring that closely because I want a really good slip fit in there. There needs to be room for the silver solder, not too tight, not too loose, and that looks really good. And then I can part that off to length. These dimensions so far have all been pretty approximate because this is all going to get machined down further. Again, we're just fabricating via silver solder the rough castings from which these fittings will be machined. A very Kozo Hiraoka approach to this. Now for the silver solder, I'm going to put some flux on the round part that we just turned there, and that's going to seat down into the base of the T section there, and then I'm going to silver solder that in there. At least I hope I am. I'm heating it from below so that the metal will be able to melt the silver solder, and immediately you can see the flaw in my plan. The hot air and the flux inside that joint are pushing the round bar up out of the joint. So I set that one aside to cool, and for the second part I'm going to make an adjustment here. I used a small triangular file to cut some notches around my counter bore there, and that allows the gases and hot flux to escape if needed, and that way I can heat it up without the part floating up out of there. That worked quite well. Got my silver solder around there, wash the heat around, make sure the penetration is good, and that looks like a good joint. So both of those were done that way, all pickled and cleaned up, and here we are ready for machining. So as you can see, we've basically created some castings for ourselves. Starting with the L shape now, I'm going to turn the round part first because the ends of the square bar are machined parallel, so they're easy to hold in the forejaw like so. So I can dial in that round part there, get that centered up. Now by design, the pieces that I've silver soldered together here are quite a bit oversized so that it didn't matter if things were crooked after silver soldering. I start by facing the end down to the final length that I want for that side of the fitting, and then I turn the OD down. So this is going to be the 1/4 40 thread that goes into the boiler, so I'm turning it down to that dimension. Quick deburr there, knock that sharp corner off, and then it's over to the tailstock die holder, and I'll put a thread on this. I really like cutting these small brass threads. They're very easy to cut, takes very little force at all, so just a little bit of handwork here makes a very nice thread. And then while we're in this setup, I will drill through this part as well. So I'll start by punching a center in there to keep my drill straight. And then I'm going to go straight in there with the final drill size. Now I'm using a feeler gauge to find the end of the drill, put it right on the end of my surface there, and then I'm drilling to depth. I want to make very sure this goes deep enough to meet the 90-degree hole going the other way, but not so deep that I go through the fitting, which would be easy to do by accident in this scenario. But with the magic of the tailstock indicator, I can do that very easily. Once again, a quick deburr, and we're on to the next step. So now I need to turn this 90 degrees, and I've got a 1/4 40 bushing that I found in my steam scrap bin, and I'm going to put that on there to protect the threads, and that will allow me to clamp this way on the part without clamping on the delicate end of my fitting there. That bushing will spread the load across multiple threads. And I've marked an X on the end of the part, and I'm dialing it in just by eyeballing the tailstock center on the center of my cross there. And this is not a very accurate way to dial something in, but small square parts can be pretty tedious to dial in, and so this is a quick way to do it in a case like this where it really doesn't matter. So you can see there's plenty of run out there. The part is also not very square in the jaws. This is all fine because this fitting is very low precision. So that quick shortcut got me as far as I need to go on precision for this setup. So I'm once again facing that down to length, and then I'm double checking that the length that I'm going to turn is going to be in a position where it's not going to hit the chuck jaws, because this is getting pretty close to the chuck here at the end, and so I'm just double checking where I'm going to be and make sure that nothing is going to crash. Always a good idea. And then I turn this down to the very small thread that goes on to the little union cone of the siphon tube of the pressure gauge. This is a very, very small thread. On the final pass there, I also faced the base there of that shoulder on that cube. Might as well make it look nice while we're here. I cut the thread next. I always like to cut the thread before drilling out these small fittings because the thread cutting operation takes quite a bit of strength in the material, whereas the drilling does not. So if it's a fairly thin wall fitting when you're done, I find this order of operations to be a little better. The trickiest feature here is the female union cone. Now luckily it's a 60-degree included angle, so I'm making that cone with a center drill. I just went in there straight with a center drill until the diameter looked about right. Then I do a test fit with the male side of the fitting from the siphon tube, and that's a little shallow. The nut won't quite feed over that and tighten down. And that's looking better. The cone should almost fully seat in there, and then the nut should be able to pass over the whole fitting and tighten down, and then the whole fitting should become rigid once that nut is tightened. And then you know those tapers are seated and you've got a gas-tight seal there. So that is excellent. Very happy with that. Now I'm going to come back in with a very tiny drill and drill that through to complete the L shape of the fitting there. So we're drilling into the cross hole that we made earlier. So I've got a very small drill there, and I've got the depth marked with some tape there, but I mean, I'm going to feel it when it breaks through anyway. And that looks good. That smaller drill was just taken from the ID of the siphon tube. I just matched that since that seems to be the size it wants to be. Onto the T-fitting now. My order of operations is going to be a little different here because this fitting has some different requirements, but I am going to start with the round section once again because the parallel machined ends of the square bar are easy to hold, and that's easy to dial in that way. Once again, I start by facing that end down to length and turning this OD. And then put the threads on there. Now for drilling this hole, things get interesting. I'm very intentionally not going very deep with this hole. I'm just getting it started. I don't want to drill into the wide part of the T because then when I drill the long part of the T out, when that drill encounters the cross hole halfway down, the dynamics on that are going to get really weird. The drill is very likely to deflect when it encounters that cross hole. So I'm stopping short and then I'll drill through the other way and then finish this hole later. Flipping the fitting 90 degrees now, I'm not going to do the trick where I grip on the threads this time because I have a T shape here, so it'll be easier to just grip on the square end. And I'm going to dial this in differently. Rather than the approximate method I used before, I'm dialing this in using the square stock method. I've talked about this in my 4-jaw chuck video before, but quick recap, you're basically rocking the piece back and forth until the needle shows the low point, and then you know that the side that the indicator is touching is vertical, and then you take that reading, flip it 180 degrees, find vertical again, compare those measurements, dial it in, and so on. So it's the same process as dialing in round stock, it's just a lot more tedious because you got to find vertical on each face as you go. Now there are other ways to do this, which I showed in my stupid 4-jaw chuck tricks video, which I will link to below, but I wanted to show this method so that you know that you can in fact dial in square bar. Now the reason I'm going to all this trouble to dial this side in accurately is because we're drilling a long hole here, and this part needs to be straight so that it comes out centered on the other side. With the elbow piece, it was much less important. So now I can turn down this side of the elbow to prepare for the threads. The threads on the long side are both 1/4 to match my boiler and the globe valve, but the short section of the T, that thread was actually measured to match the fitting on the water gauge. And this will all make sense when you see the final assembly here. But with that thread cut, I can now drill, and I'm drilling this all the way through the entire fitting. And again, this is why I did not drill the cross hole very deep, because I didn't want this hole to encounter that halfway through and cause deflection and other weirdness. So I got a nice clean straight hole by doing it this way, just with the slight cost of a little bit of an extra step at the end. You can see how nicely centered that hole is on the far side because of the trouble I went to do it that way. A change of chucks now. It's getting hard to hold the part, so I've got a gauge pin in there to protect that thin tube that forms the thread on that side that we've cut, and that's going to be held in the collet chuck, which won't damage the threads, and then the gauge pin keeps it from crushing the tube. Now there's a little bit of run out there, but not too bad. I didn't work real hard to get the collet perfectly seated there, I guess. So I turn down this side now to the OD for that thread, and once again cut the thread. I cut this thread very gently because the hole was already drilled, and as I said earlier, I don't like doing it in that order, but in this case it worked out okay. You can see how the gauge pin did its job there, and all those threads look good. Now to make this a functional T-fitting, we have to finish drilling that other side out. So now I set it up in the mill, and I'm just shifting the table around until the drill slides down there without bending. Then I know I'm sufficiently well centered, and then I can drill that out. The drill is going to follow the existing guide hole that was already there. That's why I drilled it out partially when we had it in the concentric setup before. And that fitting is now functional. I polished up these fittings with the little Scotch-Brite wheel on the Dremel there. I've shown these little tiny Scotch-Brite wheels before. They're quite handy for these small model projects. And there's my 2 custom fittings. I think those are going to work, but the truth will be in the installation. Starting with the pressure gauge, I've got some Loctite on there, and you can see how the cube section allows me to put a wrench on there, get that snug down. I want to line it up so that the siphon tube is vertical, and then the little pipe unions all thread together like so. If I did my job right on that elbow, then that pipe union will be gas tight with no Loctite or anything required. Snug that up. We'll find out how good that fit is when we pressure test it. For the water gauge, same deal. So that top fitting is the standard PM Research one that came with the kit, and then I'm threading my custom one into the bottom. Now the trick is you got to get both of these fittings perfectly lined up for the glass tube, because of course glass doesn't bend even a little, and I couldn't quite get the fittings to sit where I wanted because the commercial PM Research fitting wasn't seating all the way down on the boiler bushing. So I got out the tailstock die holder there, and I just manually ran the commercial thread through it because there was some threads at the base of that fitting that weren't very good. So that allowed me to tighten it all the way down to the boiler bushing, which gave me the alignment that I wanted on the bottom. Remember, way back when I silver soldered this, I went to a lot of trouble to hold those boiler bushings in place with a fixture during silver soldering, and this is why. Because if those bushings were not perfectly aligned in this moment, you'll never get the water gauge to fit right. And not only does the glass tube have to align, it has to be well centered in those fittings or the O-rings will never seal it properly. So properly functioning and leak-free water gauge is all down to how good the alignment on your boiler bushings is. It's very important. Now to get that glass tube to the correct length, that's obviously necessary for any water gauge. So I've seated it in there and I'm marking the length with tape. It's critical that the tube be long enough to span the fittings, but not cover any of the boiler bushings so the water can get in and out at both ends uninhibited. The easiest way I've found to cut these is to take a small triangular file that you don't care very much about because you're going to be using it on glass. It's not very good for the file. And just make a little notch and then trap it in the vise. I'm not clamping it in the vise, I'm just trapping it between the jaws to create a clean point of force there right on my notch. And then a quick motion with your hand. I'm wearing a glove in case it shatters, which can happen. And glass Yahtzee. There you go. Just a quick motion like that, and then we've got a clean break. Now I've got a little bit of a chip there. I always get some little bit of a chip there, but basically that's a clean break. So it's a little bit of a scary process, but it does work quite well. You can, of course, also buy glass tubing cutters, but an old file works just fine. Now the PM Research kit comes with a little chunk of silicone tubing from which you are expected to cut your own little O-rings. You could also just use silicone O-rings from, the store if you wanted. But these little homebrew O-rings actually work very well. I've used a few of these PM Research gauges before, and these little homebrew O-rings actually don't leak. They seem to work very well. Steam School sidebar. The water gauge is actually the most important gauge on the boiler. It's absolutely critical to keep the top of the firebox covered in water at all times. That water is what's keeping the fire from melting the silver solder and even the copper in the boiler. Water is such an incredible heatsink that as long as there's water on top of that firebox, the silver solder can't melt and it'll just keep making steam. Running a boiler dry is the most surefire way to scrap it and possibly make a very dangerous situation. Once the glass tube is kind of centered in place, then just finger tight on those fittings there. And then there's a little plug that goes in the top to plug the access port that we used to get the tube in there. I also mounted my globe valve there at the bottom, and after doing that once, I decided I didn't like the orientation. I decided to flip it 90 degrees, and so I had to take everything apart and put it all back together again. And then I can install the other globe valve on the top. That's going to be the steam output valve eventually. And then a blanking plug goes where the safety valve will be because I'm getting ready for the pressure test here. Once all these fittings are installed, you have to do another hydrostatic pressure test, this time to 1.5 times working pressure. Remember last time we tested just the pressure vessel to 2 times working pressure, just to make sure the vessel was structurally sound. Well, now we're checking for leaks in all of the fittings and such. So start by pumping it full of water. I've got the valve at the top of the boiler open to let the air out, and you can see the water rising up the gauge there. As I'm filling the boiler, I'm of course watching for leaks on all of those fittings, and of course I have some on the water gauge. Now the trick to water gauges is you have to tighten those fittings as little as you possibly can, just enough to stop leaks. Usually finger tight is enough. If you tighten them the tiniest bit too much, you will crack that glass. Now I'm using a wrench a little bit, very, very carefully there. I need to compress those O-rings slightly, but again, just making very small turns on those nuts and then checking again just until it stops leaking, and then continue filling or continue building pressure. It's so easy to over tighten those water gauge fittings and crack that glass. So I should be close to full now, and yep, I am definitely full. Water coming out of the top, so now I can close that valve. Now the boiler's full of water, no air in it, and we can start building pressure. This is just another hydrostatic pressure test like we did before, but this time I'm focused on the fittings. So right away I've got another leak on the water gauge, not unusual, but now you can see me building pressure there. We're up to 25 psi there. My target pressure here is 90 psi. That's 1.5 times my working pressure of 60 for this boiler, so you can see me pumping it up there. Closing in on 90 psi, looking good. The pump, by the way, is attached to that lower left fitting, which is where the water feed pump for this boiler will eventually be attached, but for now it's a handy place for filling and pressure testing. At 90 psi, I've got a little bit of weeping on that water gauge once again, so again, just the tiniest little snug with a wrench, just to see if that will cure it, and it did, so things are looking good. The other likely source of leaks here is always going to be the valves. I've never found a model valve that doesn't dribble, honestly. If someone knows of some, let me know where to buy them, but in this case, this one is actually not quite tight, so I snugged that up a little bit, and that mostly cures the problem, but still, they drip a little bit. Now, there's 2 things that I'm checking here. It's not just for leaks, I also want to know that the pressure gauge is accurate. So I'm comparing with the one on the pump, making sure that they both read 90 psi at the same time, and they do, so that's good. Just like the previous test, my goal is to hold the test pressure for 15 to 20 minutes, so this is looking good. We've been sitting at 90 psi for 15 minutes, and even the water gauge is bone dry. How do you like that? That's a successful pressure test. And once again, stupid boiler tricks, you can open the drain valve, nothing's going to happen until I open the valve at the top, and away it goes. And I'm going to mute that because if you quit now to go to the bathroom, it's going to hurt my retention statistics, and that's not good for the algorithm. That's basically all the fittings, and the pressure test passed with flying colors. I'm very excited with where this boiler is at right now. The last thing it needs is a safety valve, which is a bit of a story all its own, but we'll be covering that soon, and then we'll be ready to start making some steam. Well, thank you very much for watching. I hope you're enjoying this series. If you are, and you can swing it, how about helping me out there on Patreon? That's what keeps this channel going week after week. Thank you for watching, and I'll see you next time.